So this is question 3. We have two reservoirs, and I'll try to read the question because I can't even see it well, and I guess you may not be able to see it well too. Two reservoirs have 6 in difference. Two reservoirs have 6 in difference in water level and are connected by a pipe 60 centimeter diameter and 3000 meter long. Then the pipe branches into two pipes, each 30 centimeter diameter and 1500 meters long. The friction coefficient is 0.01. Neglecting minor losses, determine the flow rates as discharge Q in the pipe system. And I have drawn it here. This is the diagram. Firstly, we have a pipe AB. I'm the one that made these letterings A, B, C, D. We have a pipe AB of length, pipe 1, which is of length 3000 meters and diameter is 60 centimeters. Then it branches to BC and BD, which are of equal length. Don't mind the diagram here, it's supposed to be kind of straight, but just bear with me. Which are of equal length. L2 is equal to L3, which is 1500 meters, and D2 is equal to D3, which is not 1500 meters. It is not 1500 meters, it is 30 centimeters. So, and we have the friction constant F is 0.01. How do we solve this now? We see that this involves both a series connection and a parallel connection. So let me kind of explain something. When you have this kind of system, the fluid can decide to flow from A to B and then go to C to enter this reservoir, or that is from A to B and then go through C to enter this reservoir, or flow from A to B and go through D to enter this reservoir. So we have independent equations, one for this ABC and the second one for ABD. I hope it's clear. If it's not, just bear with me as we solve it. I think it will get clearer. So now, the total head loss, we're given HL is equal to 6 meters. So now we have HL will be equal to, let us name this, or let us number it. Let us number this as HF1 and this as HF2 and this as HF3. So now, when the fluid decides to go from A to B to C, the total head lost will be, so let me write it, when going through A, B, C, the total head loss will be HF1 plus HF2. But when going from A through B through C, the total head loss will be HL is equal to HF1 plus HF3. It's actually kind of simple. When it goes like this, let me highlight it again with a different color. So when it goes through this green, A, B, C, the total is HF1. The total is HF1 plus HF2. But when it decides to follow the yellow path like this, the total is HF1 plus HF3. The friction coefficient for pipe 1 plus the friction coefficient for pipe 3 when it decides to go through ABC, the friction coefficient of pipe 1 and the friction coefficient of pipe 2. So let us solve. Let us first find the expression for when it decides to go through ABC. This should be D. ABD. Let us first find the expression for when it decides to go through ABC. So when it goes through ABC, the expression is HL will be equal to H. Okay, let me just write it in full. Since we have to find the flow rate, which is Q, we will also be using the formula that involves Q, the discharge. So it will be 32 F1 L1 Q square over pi square G D1 raised to power 5 plus 32 F2 L2. Okay, this will be Q1 square F2 L2 Q2 square over pi square G D1 D2 raised to power 5. So now simplifying this further, we have, let us now try to get a relationship here. So HL will be equal to 32, and F, the friction coefficient, is the same for all the pipes, so that's 0.01, and then the length of the first pipe is 3000 Q1 square over pi square multiplied by 9.81 multiplied by D1. D1 is 0.6 meters raised to power 5 plus 32 0.01, and then the length of the second pipe is 1500 meters, 1500 Q2 square all over pi square into bracket 9.81 into bracket 0.3 raised to power 5. And using my calculator now, I get 127.51 Q1 square plus 4084.48 Q2 square. You can see that these answers tally with the answers that I got here. So this is our first expression. Let's call this equation 1. Now, when the fluid is passing through ABD, what is the expression that we have? When passing through ABD, what is the expression? HL will be equal to HF1 plus HF3, right? So HL will now be equal to, we already know what HF1 is, this, but let me write it down in full just for 32 0.01 3000 Q1 square over pi square 9.81 0.6 raised to power 5 plus now HF3. And how do we get HF3? The same way. We see that HF2 and HF3 are even the same thing because they have the same diameter, the same length, and the same length. 32 0.01 1500 Q2 square over pi square 9.81 0.3 raised to power 5, which will also give us the same expression, which is HL will be equal to, let me rewrite that expression, 127.51 Q1 square plus 4084.48 Q2 square. Okay, so now what do we do next? Sorry about that. So now what do we do from here? Well, let me go back to that diagram to indicate something or to show something. We can see that this is pipe 1, this is pipe 2, and this is pipe 3. For pipe 1, the discharge or the flow rate is Q1. For pipe 2, the discharge or the flow rate is Q2. And for pipe 3, the discharge or the flow rate is Q3. But we know that for continuity of flow, Q1 is equal to Q2 and Q3. Like Q1 basically produces Q2 and Q3. So Q1 will be equal to Q2 plus Q3 for continuity of flow to occur. Okay, so knowing that now, that Q1 is equal to Q2 plus Q3. But we know that Q2, let me go back up here, since the length and the diameter of pipe 2 and pipe 3 are the same, Q2 will be equal to Q3. So we can just substitute for Q3 as Q2. That means that this equation will become Q1 will now be equal to Q2 plus Q2, which will now be equal to 2Q2. So basically, Q1 is equal to 2Q2. Now, let's solve this equation now, which we know as equation 1. We know that HL is what? Let me see. HL is 6 meters. So 6 will be equal to 127.51 Q1. But let us substitute Q1 with 2Q2. So that will 2Q2 is power 2 plus 4084.48 Q2 square. So now 6 will be equal to 510.04 plus 4084.48 all into bracket, then this is Q2 square. So Q2 square will be equal to 6 divided by the summation of these two, which is 4594.52, and this equation or this expression will give us 1.306 times 10 raised to power minus 3. Now finding the square root to get Q2. The square root is, so Q2 will now be equal to 0.036, and since we know that Q1 is equal to 2Q2, then Q1 will be equal to 2 times 0.036, which is equal to 0.072. So Q1 is equal to 0.072 meter cube per second. Don't forget meter cube per second. That is Q2 and Q1. So we know that Q3 is equal to Q2, which is equal to 0.036 meter cube per second. I hope it is clear.